Hello, friends. Here's a demonstration that I do in my physics class where I'm talking about voltage and electric fields, and then sort of transitioning to the idea of circuits. I put two electrodes in water. I turn up the voltage and put in an LED. So here's what happens. Everyone listen up. So here's a voltage source. I'm going to turn the voltage up to about, let's say, 25 volts, 26, almost 30 volts. Zero. Initially, it was at zero. All right. So now, guys, listen. So the two wires are connected and they're sitting in here. This has water in it. Do you see the water? Okay. So what that means is here's a high voltage, here's low voltage. This is like a mountain, this is like a hole. And there's an electric field that's created here in the water, but you can't see it. Since there's an electric field there, if I were to take like a little proton and put the proton in here, the proton would shoot from one side to the other. It would shoot downhill. This is like a really steep ramp right here between these two. You saw in the packet, guys, listen, you saw in the packet there were some examples where there was like a line, one side was positive, one side was negative, right? It's this kind of thing. Now, I don't have protons that I can throw around, but I do have this thing. This is called an LED, light emitting diode. You have like LED televisions and screens and stuff like that. So it's just tons and tons of tiny versions of this. When you run electricity across it the right way, it lights up. It's a light emitting diode. Now, if I put this in here, it's made of metal. Metal is a conductor. That means the electrons are free to move. And so they're going to be pushed. The electrons are actually going to be pushed uphill. When I put this in there, you see the light turns on? It's not connected to any metal. It's just sitting in the water. Put it in there and the light turns on. And you can see it really well if you're like above. That's how it works best. Right? In the water, out of the water. In the water, out. At just one point, no. But if I connected two different points, then I could, yeah. Now the thing is, like what we did here, it was a shock. It was just the stuff, the electrons just moving quickly. This would sustain the shock. If you're if you're connected to like an outlet or something, that's a continuous charge, and so that could really mess you up. This is just a quick discharge, right? But notice what happens if I put it in this way. There's no light. It doesn't light up at all. Why not? Because where the two sides are, that's not a difference in the height. That's not a difference in potential. There's only a difference in potential if one side's on high and the other side's on low. Right? So that's the only time the light turns on is when you have that happening. Okay. Oh yeah, so what happens if I go like this and then I turn it, it gets dimmer and dimmer until there's nothing. And then the light gets brighter as it gets more and more like that, you could say. Right, so here it's dim, getting brighter, and then when it's the most downhill, yeah. It's this thing. So I was just noticing something here. Hmm. Sorry, what's your question? So this thing, the LED, it does matter. Light emitting diode. So what a diode does is it only allows current to flow in one direction. Um, and so if it's oriented the wrong way, current won't flow. Like in an electric circuit, exactly. Yeah. So thanks for watching. Don't forget to like and subscribe and share.